Okay, so some differences of area. So we can use this method if we have something integrating with respect to the y-axis, and instead of changing your formula, if you can make a clever approach, right, this could save you time, particularly if the solving and getting x as subject, for example, is not so straightforward. Okay, so sometimes you will have to use this method, okay, but most times you'll be able to get your x's in terms of y if you're swapping the axis over. Alright, let's have a look at a couple of examples. So, find the area bounded by the curve, y equals x squared. Y-axis and y is 0. Okay, there's the condition. Right, so step number 1 always gets the area to be bound. Alright, so I know it's in the first quadrant, and I know it's a parabola. From 0 to 3 of the y-axis, and that's the region I need to find. Okay?
I bet you the answer is 2 root 3 units.
2 root 3. We'll find out. Okay, so what we can do, alright, if we can enclose the rectangle that we need to find the integral of, alright, so we need to do a bit of maths to be able to do that, and then I can integrate with respect to the x-axis. Okay, so the area is going to be the area of the rectangle. Take away my integral of, which is going to be some function of x dx, well, it's really x squared. Okay, so just a general approach.
Root 3.
Okay, so we know this distance is 3. How far is it from here to here?
Root 3.
Yep, because y equals x squared, so y is 3. So x squared is 3, x is going to be plus or minus root 3. And of course we're in the first quadrant, so that must be the positive root 3. Okay, the other one comes from, of course, having the parabola continuing in this direction here, but we only need this area on this side. Okay? So, the area of the rectangle is going to be root 3 times 3. So in other words, 3 root 3. Take away the integral. Now, what you are now doing is finding this area here to take away from that rectangle. Alright, so the bounds are root 3 and 0. And I can integrate with y the subject, which I've already got. X squared dx. Okay, so this is an alternate way. Instead of rearranging formulas, okay, for this example you probably would rearrange it, okay, but for some you might find it easier to do something different, and some you may find you had no choice but to do that. Okay, 3 root 3, take away the integral of x squared to x cubed over 3 from root 3 to 0. Okay, you've got to watch these brackets now. So, 3 root 3, take away. Alright, so it'll be 3 to the half, all to the power of 3, all over 3. Okay, just avoiding my thirds for now. Alright, take away 0. Because if I substitute 0 over x3 over 3, we'll get that. So this will become 3 to the power of 3 over 2 using index laws. Divide by 3 to the power of 1, which is 3 to the half, which is root 3. Take away 0. So it'll be 3 root 3, take away root 3. So remember your third laws, you treat them like terms, is equal to 3 root 3 take away 1 root 3, which is 2 root 3. Okay, and I'm pretty sure we had done that question, and we've got the same answer. Okay? So, that's the alternate.
Science.
Okay, B. We got y is the square root of x, y-axis, and y is 1 and y is 4. Find that area. Using the sum difference, okay? So because it's under this heading. Right, so that's the first thing you need to do. The very first thing in all area question, you need to do what? Sketch. Okay, make sure you understand exactly what you're finding. Okay, or you have a good representation of what you're doing.
Please come back to me.
Right, square root of x.
Oh, right.
So the curve that increasing at a decreasing rate, and we'll speak more about that sort of terminology in geometrical absolute calculus, which we'll do next term. Alright. Right, so from y equals 1 to y equals 4. Okay, you've got to be careful with this one though.
I feel that the answer is going to be 21.
Right, so what do you have to be careful of this time?
It's not all the way to the bottom.
Yeah, so if I drop this rectangle down here, I've still got this area unaccounted for. Okay, so that's what I'm finding, that area there. Okay, but I've got to be careful about what I do next. Okay, so what would I do?
No, the side is 3.
Pardon?
Take away 1. So make sure that you have the right.
X plus 1 squared. Oh, whichever.
Okay.
So 2 times 3.
What by 3?
No.
I don't understand what you're saying. What are you saying by 3? The way you're saying times 3.
Which is 4 take away 1.
Oh, are you saying do this? Oh, okay, yeah.
Oh, that wouldn't work, would it? Because the wall, it doesn't start.
Yeah. That's the one.
Well, bugger.
So, what's the alternate?
Move everything up. No, we just did that.
Why don't we do this?
Oh, now you have to find food. Oh, no.
Alright, so y is 4. The formula, so y is the square root of x. So 4 is the square root of x. Okay, what number squared do we get? What number take the square root and we get 4? Okay, so x must be 16. So 16 there. Okay, again, y is 1. So y is going to be the square root of 1, which is 1. So this one we're really going to have to set up 2 different parts. Okay. Okay, so setting it up. So the area is going to be the area of whole rectangle. Take away the integral of the whole thing. Okay, so from 0 to 16. 16 to 0 of my y equals some function of x to the half, dx.
Take away.
Take away area little rectangle okay, which is that one there. Well, now it's a square.
It's a square on my paper, so.
Alright, now then we have to do the integral from 1 to 0 of this part of that curve. So practically, would this be a way that you would do this, the sum different? Okay, no. Alright, but I'm pretty sure there's a question exercise in this section where you are asked to do it this way.
No.
So at least you're happy because I'm doing it here for you first. Okay, so it's going to be 16 fours, so 4 cubes, this is 64. So 16 times 4 for that whole rectangle. Minus the integral, sorry, already done it, minus 2x 3 over 2 over 3. Alright, so we've seen a couple of examples on how we integrate square root of x. Alright, so I'm just writing it down. You can do that straight away if you're comfortable with what you're doing. Bounded by 16, 0. And that's going to be positive because we're going to have 0 and 0 for the end point. That way I can do the second term in each of those parentheses as 0. Alright, so that will help me.
Why is it 2x?
Pardon?
Well,
Because it was divided by 3 over 2, and then I'll flip it. And so like I said, I've done this about 2 times already today. So I'm just doing the result. Nice to see you so paying attention. Alright, so take away the area of the little rectangle, which is a square. Alright, so 1. 1 by 1 is 1. Minus the integral, sorry, I should have done that again. The same thing here, but the end point is going to be from 1 to 0. Okay, so minus 2x to the 3 over 2 all over 3 from 1 to 0. Okay, so that whole thing is being subtracted. Okay, equals 64. Right, so the square root of 16. Okay, so the square root of...
You got that right.
4. 4 times 2, 8 over 3.
Okay, so step by step for the others. Alright, so the 16 replace for x. Take the square root of 16, which is 4, and then cube 4. Okay, times 2 divided by 3. Be 128 over 3. Take away, in brackets, 1 minus, open brackets again, and this one's just going to be 2/3 because x is 1, 1 to the power of any number is still 1. And minus 0, because the second point here, probably should show that. Anyway, done enough examples, hopefully remember what we're doing. Alright, what's that total?
21.
Not quite.
So 1 take away 2/3 is 1/3, so 64. Take away 129 over 3. 63, so 60, 40,
We got the wrong
43.
answer. Maybe. That was just a result.
Geez, we ever heard that wrong before.
That was the wrong answer. That was the well, that's just a part, but that is the
Yeah, mine always not.
Right, so that's the first two or do the next two Monday next week.